Well, good day, everyone. My name is Bradley Needham with Developmentor, and today we're going to be looking at a comparison of Swift and modern C++. So we're going to just kind of compare and contrast some of the features, both of these being modern programming languages based on C. So a lot of the syntax looks very familiar, but excuse me. But some of the functionality is a little bit different. So the first thing I'm going to be doing is I'm going to be going over the syntactical differences first, kind of just the basic differences syntactically between the two languages, and then concentrate a little bit more on some of the functional differences between the two languages, some of the behavior that occurs differently. It's just important, so if we're programming back and forth between these two languages, what we see the behavior being so that we can understand how it's going to work in any particular environment. So during the webcast, you're welcome to ask questions at any time using your GoToMeeting. There should be a little section in there where you can type in a question. I will try to get to them as we go along. Some of the times I'll usually wait for some of the questions till the end to respond to them if we're in the middle of a particular discussion and it might distract too much from it. But I'll also try to hold some time at the end for any particular questions that you didn't get answered, and I will go through the list again of the things that weren't answered and see if we can address some of those in the best way possible. All right, so let's go ahead and begin and see what we're going to be doing here. Like I said, it's a comparison of Swift and modern C++. I'm going to start off with some of the syntactical differences. And what I've done here is just kind of a brief, kind of outline of the things we're going to cover: comments, variables, conditionals, switches, loops, and then talk about functions, and then get into some more of the functional differences when we talk about structures and classes. I've laid this out, so I have two Xcode projects up side by side here. I have a Swift project on the left-hand side, and I have a CPP project on the right-hand side. You notice these are basically starting with the same functionality done in each of the languages. And so we're going to just kind of discuss back and forth. Sometimes I'll implement something in C++ and then show you how it gets done in Swift. And other times I'll start with Swift and go back to C++. So when we're starting here, the first thing I just put in there to discussion is to talk about comments. As you can see at the top, we have the standard / comment, which is from the beginning of the / to the end of the line. Both languages also support multi-line comments. I'll put that on a second line comment. And they start with the / and end with the //. The difference here being in Swift is that this standard multi-line comment in C++ and C and most other C-based language is non-nestable, meaning I cannot have another comment in here that is nested with a / and a / because the compiler basically interprets the beginning token here of the / to match with the end token. Just as, again, one of the little syntactical differences here in Swift is that Swift actually allows for this nesting of the / comments. This is still perfectly valid code. So again, sometimes if you're moving or porting comments from one application to the other, from going from Swift to C++, you're going to have to be aware of that because you're going to break just even your comments here if you run into that problem. So I'll do this and say, nesting not working, right? So I had to do the //. All right, so that's one little thing to start with the comments there. So pretty much the same, but little kind of syntactical difference that does exist between them. Structurally, here I'm basically creating two command line applications. So basically a simple application that takes input and output from the user on the command line, some sort of utility to that effect. And so I have to have an entry point for them. In C++, the entry point for applications is, of course, the main function. So I declare the main function, and I can also pass parameters here if I like, but we're just going to do creating the main function with no parameters. And this will be the beginning and the ending point of my execution. So anything I do where I launch off other functions or that type of thing, I have to do from within the main. In Swift, this file, being main.swift, actually has special meaning to Swift. And in that case, most Swift files, if it's not the main.swift file, most Swift files, you cannot directly execute code. You have to have a class or a structure or a function, much like you do in C++. But the main.swift function has special meaning to the compiler and the linker when it puts the stuff together in Swift, saying that this whole file itself is the main entry point. So I can actually put any line of code that would be executed, and it will be executed from top to bottom. So that's just one of the other differences. So main.swift, even though this one's called main.cpp, that doesn't mean anything to the compiler necessarily. You still have to have this main function. But in Swift, if you want to create a command line application, you can use main.swift. Of course, a lot of the applications we build are iOS applications or more graphical user interface OS 10 applications. So you would have a different entry point in those cases. Okay. So I thought I saw a question, but I don't see one up here. Okay. All right. So let's go ahead and continue on with variable declarations. So important thing to note about both languages, Swift and C++, is that they are statically typed. So unlike a dynamically typed language like Python or JavaScript or something to those effect, you have every variable that you create actually has to have a type. Now in Swift, when we declare a variable, we always start it with either the var or the let. And I'm going to talk about the differences of those in just a minute. But var specifies for me that it's a variable type of some sort, and then I give it a name. So like X, it has this particular name. Now with Swift, like I said, it's a type strict language. So every variable, X here, has to have a type. So with the type, I can specify it by putting a colon and then putting the the int int type there, specifying that it is of type int. With with C++, right, I can do something similar. First off, in C++, you can do it like this, where you specify the type previous to the variable name. But in modern C++, it's much more common and more idiomatic to use auto. Auto, much like var, will do some sort of compiler inference to figure out what the type is, some type inference. So in this case, with auto, though, in C++, if I don't actually specify the type, I must specify an initializer so that the compiler can determine what to actually initialize this to. So if I put a literal like 5, the compiler assumes here that 5 is going to be of integer type, and therefore X will actually be of integer type. And the same thing here in Swift. If we say equals 5, we're going to get, oh, this is an int type, an integer type, and so therefore X is going to be of type integer. So I'll just put those both up again just so we can see X with the strict type with no initializer. Here, to do that in C++, you would have done int X, right? To not use the type inference, but allow for it to run. And in this case, you just do the same. They look the same here. The difference here is auto versus var. Notice the other thing I haven't done syntactically is there's no semicolon here. This is perfectly valid in Swift. However, both cases in Swift are valid. I can have the semicolon at the end, or I can not have the semicolon at the end. In C++, I'm required to have the semicolon at the end of each statement. Let's just do another output here so that we can kind of do the same thing that we're doing on both sides. If I run this one, that runs that way. If I run my other one, this one also runs hello world and 5. Okay, so variable typing being strict things back and forth. The other thing to watch out for just in the difference in Swift and C++ is the conversion of promotion of types. In C++, if I created, say, a double, y, and I simply assigned it the value of x, right? That would work. I could go ahead and print this out as well if I wanted to. And actually, I'll change it. Well, let's just do y here. They both should come out as 5. Build succeeded. Everything worked fine. In Swift, if I try the same thing, var y equals x, and specify it here. If I did it this way, that would be the same as, what, putting auto here. Auto there is going to give me an integer, so y is actually an integer, not a double. Here, I force it to be a double. And how do I force that in Swift to be a double? I use the syntax where I have a colon, and then specify the type that I'm going to use. Okay, notice right away in Swift, I get an error. So not a warning, but an error. And in C++, I'm not even getting a warning. And this is just another way that Swift is trying to make it a little bit safer in the way that it does things, in that this is not allowed. There is no automatic conversion. Even a promotion from an integer to a double is not allowed in Swift. So in this case, if I wanted to do this, I would have to do explicitly tell it that I wanted to create a double type from that, from the integer type that was passed to me. Okay. All right. So this is type strictness, static typing, variables, right? There's a lot of different types here that exist for Swift types if you want to create them of a particular type. To know, say, var a happens to be of a uint 32 is what I'm looking for, a particular type. I can still assign it to the integer value. The only time you'll find that there is some sort of type conversion that can occur is that, notice the compiler is happy taking a literal and then converting it to a particular type that you're going to use. Even though the default type for this literal would be int, it'll go ahead and do the conversion there. If I want to convert it from a variable that already has a strict type, right? In this case, the uint 32 is fine, but if I went from, say, let's try a uint 16, I'll probably complain about, is again, it would like to have the conversion. It's not going to allow me to convert an int because it's possible the int could have more information associated with it. Again, if I use the literal, that's still perfectly fine. Okay. For C++, we also have the types because we are C99. Again, this is modern C++. C++11 is now C99 completely standard compatible. And so that means we can actually have types like uint. You know, we can do a uint 32 as well. A uint 32 type y equals, you know, or not y, let's use the a, equals 4 or something to that effect. We again have a wide range of types, very similar to the way Swift has a wide range of types that are going to be specific to whether it's an unsigned int or a signed int, and then what's built in on the type. Okay, so let's see those types. Let's go ahead and clear these, get to this section. So some of the other things, so we, again, strict typing, we can specify the type by using var. We have a bunch of different ones. The other big types that are there, so the built-in types for Swift and the built-in types for C++ are pretty standard. The one that, again, changes in Swift itself, it has a string type. So if I say var s equals hello, the type of s is not as it is in C. If I did the same thing over here in C++ and said auto s equals hello, the type of s would actually be a constant char star. And I can determine that and just kind of look at that if I want to in C++ by getting the type ID information of s and printing out the name and have the compiler tell me what it expects the type here to be. And you can see it's kind of cryptic, but it's the Clang interpretation, which is a pointer to a constant character. If I want to actually have a string type, which is what we're getting over here in Swift, which is actually a Unicode string type, I can use I can actually use the string library type. So it's still not built in directly to the language, but I can use the string library type. And there's two different ways. In C++11, I can certainly specify that the type I want to create is a string and pass that to that constructor. So I'll get that type there. So again, it'll create it to a string. But this string type itself is not Unicode still, right? This string is a standard ASCII string type. If I want to change this, right, I can in C++14, I can use a suffix, basically a literal, string literal here. I have to do a couple other things like using and namespace and stood string literals. Okay. But this allows me to, this will actually then create a string type as well. And just so we can see the difference here, if I have a pointer to constant char here and I run it, I end up with clearly not the same type as a pointer to constant char. It's a pointer to a string templatized type that runs over a character type here. If I want to make it a Unicode string, basically using UTF-8, I can do it this way by specifying the literal here is that the string literal itself is going to be UTF-8 characters, and therefore the literal here at the end of the postfix s will convert this into a string of the appropriate type. And if I run that, I get the the type over a wider character, basically the multi-byte character set for Unicode in that case. By default, and of course, so in Swift, it's a little simpler, just because it's added directly into the language, is that the string type itself is a built-in a Unicode type. But again, in C++, 11 and in 14, we have things that make it a little bit easier for creating those types and utilizing them. All right, let's go. So there's the string types. We have those. We have variable types as we specify what they are. Now let's talk a little bit about var versus let, right? I said var x equals 3, and I have let y equal 4. In C++, the way we deal with this is the difference between a variable type and a constant type. So in Swift, we introduce constants via the let syntax and variables via the var syntax. In C++, we would say something like auto x equals 3 with a semicolon, of course, and that'll give us the non-const version. Or we'll say const auto y equals 4. All right, so this is equivalent to, say, the let syntax in Swift. And that means that basically here with my var, I can say x equals, x plus 3. And of course that same, we also have the condensed operators, the plus equal here that would also work. But I cannot do that for y. So y equals anything, just even y equals 5. Again, I will get an error. In this case, the build cannot assign to let value y. And that's equivalent to if I just copy and paste these over here, so you can see how similar the language is. If I copy and paste these over here, we basically get, I've got to put semicolons at all the end of these. Semicolon, 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 right? So we're pretty much getting the same error here. Read-only variable is not assignable. So constant, making something constant in C++ is the same as using a let in Swift. And I'll talk a little bit more about that when we talk about the differences structurally between or functionally between value types and reference types, which in C++ we determine via the variable itself, and whereas in Swift they determine it via the type of its creation. Okay. All right, so let and constant. Let's talk a little bit now about arrays, just so we can see the difference between how we might use an array in C++ and Swift. So arrays are built-in types. A dynamically growable array is simply a built-in type for Swift. And the way we specify that is if I say create my array, again, I can specify its type if I want. And you specify it with the square brackets here and the type internal to it of the array that you're trying to create. Now I can, this will just create the variable, right, the array of that type, and at some point I need to initialize it to some values. I can either do that later, like array equals, and then create a set of values of integers, point in here. This will work, or I can take that initialization, right, instead of doing a variable creation and then an initialization, I can do the initialization or variable creation and then assignment. I can do the initialization here, right in line when I create it. Now, an array in Swift is much closer to a vector in C++ because it is a dynamically growable object, not a simply a static C array as we would see in if we tried to create and initialize an array directly in C++. One of the things that we can do, again, so the difference here is still you can have an array, and then you can have a constant array using let, all right? And that'll again determine whether you can change the variables or not. Let's complain about Just sometimes it complains the error before it actually saves the file. So there was no error there, it's just the saving of the file. All right, so in C++, right, so if we're thinking about a conversion, if we're going between Swift and C++, wherever we're using arrays in Swift, we want to think that we're going to be using a vector. So again, I can still use auto, array, and I'm going to set it equal to use the type inference by the compiler, but I will have to specify it happens to be a vector, and it happens to be a vector of integers that I'm creating. But I can use the uniform initialization syntax, which allows me then to, very similar to the way I created the array over here in Swift, I can do that with the vector in this side. Okay. Same type of thing here with the constant vector. I'm going to be using this one. I can change this one to C, but again, instead of just saying let, I have to say const auto car, which gives me a constant vector on this side. So notice some of the differences. Again, for Swift, I don't have to have the specification here of the type, right? The compiler will use type inference to figure out that this is an array of integers, right? You can do that here. And we can do some other trickery to make this figure out, again, whether this is integers as well. But this is probably the simplest, most straightforward thing. If you know you're putting integers into this vector, you can do it this way. And again, notice we allow now in C++, very similar to they do in Swift here, you allow this trailing comma so that you can either have it or not, right? I can take the comment out or the comma out, and it will correctly create the right number of elements, realizing that you either just don't have the final element or you do. Makes it easier when you're expanding things that are statically built up in sizes like that. All right. So now that we have basic syntax for creating variables and things like that, let's look at some of the conditionals we can do. So conditional is basically an if statement, right? So we're going to have basically conditionally execute a little bit of code for one reason or the other. And in C++, let's start with a auto x equals 5 again. That'll be our variable we're going to use for our conditionals. I'll go ahead and cut this out here. So I can say something like if, notice I start with that parentheses, let's say x equal 4, right? Then I can have a condition, stood cout, x is 4, and a \n, and then I can have an else condition, else stood cout, x is not 4. If I run this, or so I get the x is not 4, and I'm going to take out this hello world so it stops repeating itself over and over every time we do an example here. So if I want to take this thing here and just copy and paste it over to Swift side, I can do that in the way that I have it generated. The only difference here is I just have to set var, right? Var to this case, and then of course var prints are a little bit different, right? I'm just going to change this to print line. Print line, actually I'll just change it to print so I don't have to remove the \n. Don't get doubled up on it anyway. Put this in print. And then this should be pretty much the transfer, same thing. Now, a couple of things that we can do that are different in C++ versus Swift syntactically. In C++, perfectly valid to drop off the brackets if I only have a single statement, right? If the conditional clause only has a single statement, it just basically ends with the one semicolon, it's allowed. But remember also in Swift, you don't even need the semicolons in the statement. But one of the rules in Swift is that you must have the curly braces. Even if you only have a single line, an if statement will not be constructed correctly if you don't have the curly braces. So if I remove the curly braces, even from that top if, the first thing it's going to do is say, no, expected the curly brace after the if statement. So this is valid in C++. Notice I can run that and I will get the correct return here. This is not valid in Swift. You must have the curly braces in order for it to work. The other difference syntactically in Swift that you'll notice is that in Swift, you don't need to have the parentheses. So I can basically not put in parentheses here and still have the conditional expression evaluated. Run it again. This one works fine. In C++, I have to have the parentheses. The parentheses are necessary. If I try to run this, of course, it gives an error saying that it expects the parentheses for the expression. Okay, just a couple other differences here. In C++, it is allowed to have an assignment here because the conditional expression can evaluate against an integral value, an integral constant. In Swift, that is not allowed. It becomes an error, right? They won't even compile your code because it cannot evaluate the conditional on an integer. It can only evaluate the conditional on a Boolean. Notice that most C++ compilers here will help you out depending on your warning levels and certainly tell you, hey, this is a conditional without parentheses. You're trying to do something that doesn't look like you're actually trying to do that assignment. You probably meant to do a comparison, right? Some sort of comparison here. But this is just the error versus the versus a warning. Any other conditionals work, logical operators work here. As long as something resolves to a Boolean type, which is bool in Swift, that'll work in the conditional statement. Okay. All right. Conditionals. Again, main things to take away from that, right, is that in Swift, parentheses are not necessary, curly braces are. Difference in C++, parentheses are necessary, curly braces are not if you have a single statement. All right, so the other big one to look at is kind of the switch statement. I want to kind of give you guys a kind of a brief overview of the switch because the switch is probably one of the biggest differences, has quite a few differences in Swift versus C++, syntactically and in kind of the default behavior that results from the type. So the easiest way to express a switch statement is to start with some sort of an enumeration, right? I mean, I could always switch on an integer or something to that effect, and in Swift, you can actually switch on strings as well. But let's use an enumeration just so we can test this out. So let's in Swift, it's pretty easy to create an enum. Same way, again, syntactically as you might for C++. You give it a enum and then you give it a name. The difference is that, of course, inside here, we don't just specify the types underneath here or the enumerated values here. We actually have to start with saying case. We want a case, and then we can kind of comma separate all of them for what we are. So let's just say Monday, Tuesday, Wednesday, Thursday, Friday, and then Saturday and Sunday. So just even starting with this enumeration, let's move this enumeration over to C++. Over here, the enumeration of C++. Couple of differences, right? Of course, there's that semicolon. We've got to have that semicolon everywhere. And other than that, it's just removal of that case, where we say that this is one of the cases that's associated with enumeration. Now in Swift, enumerations are much more powerful. There's lots of other things that you can do. You can actually carry values with enumerations, but it'll be beyond the scope of this particular talk, and we'd never get through most of that stuff in this hour. So I'll just do the kind of the simple one here, simple case here. So this is how you declare the enumeration. So then how might I use it in a switch statement, right? I can use auto today and equals, say, day, : Monday. Right, that's how I'm going to express the type here in C++. And this is just for standard C enumeration like this. We'll look at an enum class or a scoped enum in just a moment. So then what I want to do is have a switch. And notice that, the IntelliSense gave me kind of, how the switch statement is going to be laid out for a C++ version of the switch. Let's try it down over here. If I say var today equals day. In Swift, there's no, say, scope resolution operator where you don't use it the same. You don't have the scope resolution operator like you do in C++. We just use the dot operator to represent that kind of that enumeration that's there. And then if I have my switch is just going to have today. I don't know why the IntelliSense didn't help me out with this one. But it's not going to be the same laid out as here. So let's just do the C++ one today. Switch on today. And then the case statement, the constant, I only get one constant. So I have to say Monday. And maybe I'm going to print out the stood, cout, get to work, \n. And then I might have the default and then the run. And if I run this, I say today is Monday, then I get the get to work. If I want to do the default, I come here and I can say probably get to work. Yeah. That one, if I change this to Thursday, and of course I get the probably get to work. If I take out the default, let's notice something here with C++. If I take out the default, I get a warning. And again, this is just the modern compiler giving you a warning of something, is it allows me to, okay, look, 6 enumeration values were not handled. I didn't handle Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. If I do the same over here in Swift, so I use case, notice that I'm going to say dot Monday, because in Swift the types are the enumerations are scoped, right? Just like unlike in the raw enumeration type that I have over here in C++, it's not scoped. I mean, again, I'll show you into scoping in just a minute. But let's put in the case here and let me go print line, and let me copy this. So I'll just do print line, print, and then say get to work, /n, and then I will have a default. Let's just copy. I think I have a default in here typed in already. So default, just got to change this to a print. Print, probably get to work. Into that one. And then let's delete this. Okay. All right. This was my beginning point, kind of on the same as over here on the C++ side. I got this warning here, 6 enumeration values not handled. In Swift, if I remove this, okay, and try to run it, it's going to actually fail. And it says the Swiss must be exhaustive. So the switch statement has to be exhaustive. In C++, it's good if it's exhaustive, and the new compilers will help you and tell you if it's not exhaustive. But in Swift, you have to have it be exhaustive. So I need that default case. The other thing to notice here, as example, when I had the default case here versus the default case on Swift, you might notice something missing from the cases in Swift. And the same thing if I add another case down here, let's say for Saturday and Sunday. Change this one to Saturday maybe. Change this to have fun or something. Okay. In that case, if I run this, I still just get the one get to work, which is what I'm expecting here. If I then have another case here for, say, Tuesday, I might want to, instead of duplicating this code here, right, I might want to just call the get to work one time, but for Monday and Tuesday, do that. If I delete this and try to run it, I'm going to get a compiler error. And the reason why this will work in C++ and how we expect the switch statement to work in C++ is very different than the way it does in Swift. Is it here, if I change this one to Tuesday, and then remove everything from these other two cases, I get the behavior I'm expecting is that maybe it's going to go ahead and run through, excuse me, fall through the case of Monday and then go into Tuesday and then print. If I change this back into Monday, I run it, and that gives me the get to work. It's going from Monday through Tuesday. It's falling through. And that's the default behavior in C++. The default behavior in Swift is to break, which means that if I leave this case empty, the Monday case empty, the default is to break. And so it's not going to do what's expected, and even it's erroring out. I would have to put something in here for Monday. There's a keyword fall through that you can use to get the same behavior as your default behavior here over in C++. However, that's not really the best way to do that with switch statements in Swift. It's better to actually use the fact that the switch statement allows you to take and put multiple cases for a particular single case. So notice I don't have to have a separate case for Tuesday. If I'm going to be doing the same thing, I simply specify, okay, this is going to be Monday, comma, Tuesday. And depending on what you're using, you can also do things like ranges. Currently, I don't have any range set up for the enumeration, so that wouldn't work. But switch is pretty powerful. The only other things to see are different here between C++ and Swift is, again, the same type of not having to have these parentheses if you don't want to, but you can have them if you'd like. Right? But again, the main difference between these two is the fact that you have the default behavior as being break versus fall through, and then you also must be exhaustive. The switch statement must be exhaustive. And that doesn't mean I have to have a default, right? I can get rid of my default if for the enumeration I have specified all of the values. So if I put Wednesday and Thursday and Friday, and then run it. Again, the build succeeds. I don't have a default case, but since I have exhaustively created switches for or cases for every possible enumeration type, then it will work fine. Okay. All right, so let's move on then from here, from switch statements. So we've gone through if statements, we've gone through switch statements, we've gone through variables, creations, and we looked at enumerations. Let me just show you one more thing with the enumerations I just point out here in C++. Again, there's also scoped enums, which are basically also help for not polluting the namespace here. In that case, I have to actually specify the that this enumeration comes from the date type so that the three-letter MON doesn't pollute the namespace at this level. Okay, so it's just say a enum class here. You're going to do that. Okay, so let's go ahead and delete this part. Let's get rid of the using string literals as well. And clear out this section. And we'll clear out this one here. Okay, so let's move on and talk a little bit about loops. Just real briefly about loops. We have a couple of different loops created. Swift supports 3 of them. You have the while and the do while and then a for. Right, and we're going to mainly talk about the for loop because there's really a couple different varieties of for loops that you can use, and that's very similar in C++. Again, C++ also has the while and the do loop, pretty much the same as you have in Swift. The difference, again, is going to be very similar to the way the if statement is different. You're not going to need the parentheses, so if I have a while loop, let's create an array here. Let's create a vector, auto array equals std vector of int we'll create, and we'll initialize it to a bunch of different values again. All right, and then if I wanted to loop over this vector, I could do something similar to, I could do using iterators. I could say auto it equals array.begin, and then I could say while it not equal to array.end. That's my condition, and then I could do something like my printout std cout star it, and then a space maybe, and then of course got to make sure I increment my iterator, and then std cout my value here at the end just to get my array printed. So that's one way you could use a while. The only difference while, this could be the same, any type of value I could put in instead of doing the iterators, I could do it with it equals 0, while it not equal to, instead of array.end, array.size, which is the size of the value here. Then I'm going to actually print out array sub I, and then I++ is still going to work. This is it, sorry. Print that out. Again, get the same thing. Let's take this and pull it over to Swift, just so we can see how the while loops works. Again, replace the auto with var. Replace this creation, right, with a square bracket, because I'm just going to have it create the internal array here. While I is not equal to, it's not size, but count. Right, same type of thing. Again, everything else should work the same except for our printing. We're going to print it. Print the value. And actually I'll use something that's here in Swift, which is called string interpolation, and allows us just to, this is how we kind of print out the values in Swift. Use that backslash and then parentheses here. And then notice I kind of added the space. This is like the extra space that's added in the thing printing out. And then here I'll just put a print line, which basically does the same thing, print line. Print line. Run the Swift side. And down here, you can see in the output, we're getting the same values and same run through there. Okay. So that's, again, the while loop conversion. So again, I'll talk more, and then a do while just means you do the do first. And the difference here is that in Swift, I can do this, right? I can remove the parentheses here. In C++, I have to have those parentheses. If this was only doing one thing, it wasn't incrementing and moving, I could put it in one line, and I can actually do that by doing a post increment. If you want to be tricky over here, post increment, I can remove the while, and then I could do the same thing in here. Post increment it, make it a single line of everything there. This is a single line, and in C++, notice again, we don't have to have the curly braces, but we do have to have the parentheses. So those are kind of the major differences between the two things. Okay. All right, so the other loops, I'm going to leave the iterator up because I want to, or not the iterator, the vector or the array here, because I want to go ahead and talk about the for loop. So let's go here and talk about the for loop. So in Swift, there's a couple different variations of for loop, just like there is in C++. You have the standard, most common for loop that we've seen in C languages for a long time, and that's where we do our for, and we can specify. So again, in Swift, we're always specifying with a var or a let, depending on how we want to use it. In this case, we're going to do a var I started off at 0. Here's where I do need to use a semicolon, right? Because the for is a single expression that allows me to have 3 different statements. The initialization, the test condition, and then the increment. So I do need to have a semicolon here to separate these. Even if I don't need to have the parentheses around those 3 statements, I need to have the semicolons to separate the 3 statements. So then I is less than array.count and semicolon, and then we do an increment plus I. And in internal, we can do our print and have it add the space. So we do our quote, our backslash, same thing we had there, array, sub, I, and we can do it in one line here, I++, and a space, and then our end, and then we can print line, move it. So let's clear the output down here just so we see it. Output's cleared, we rerun it. And sure enough, we get the printed out what we expect. We want to move this to C++. Very similar. Again, the major differences are, of course, we need to have the parentheses. We don't use var, we use auto. Over here. And then the only other change is, of course, how we do the printing. And we use stood out for this case, stood C out. And we don't have to have this part of the value. Oh, sorry, I don't want to delete all of it. Just that part. And that. Semicolon. And then we can do a stood C out, the backslash in at the end. Go ahead and remove the output from here. So at this point, change out, of course, count doesn't exist. We have size instead, and that should work. Okay. If we then want to do a different type of loop, which is the range-based loop in C++, a different type of for loop, range-based for loop, we simply start with an auto, and instead of, we're just going to call this, say, val for the value, total value. We're not going to use a semicolon, we're going to use a colon here, and the colon is going to say for every item in that value over array, the value is what we're going to print out. So notice this is a range-based loop in C++, basically allows us to go over every element in this collection, extracting out each value, whatever it happens to be, and allowing me to print it. If I clear this again, right, and we run it, we can see that we get, what have I done here? I'm missing a point, auto array size. Oh, I'm double incrementing. Sorry, in my loop. So I was like, yeah, we missed these ones here. So in this loop up here, I don't want to double increment. Same thing I'm doing over here. That was because I was using a while loop before and I didn't have the increment on the for loop. With this one, I just want to print out the value. Same thing here, just print out the value to get the correct elements out. So I rerun this one. Now we've got the correct loop going. Let's see if that was the question here. Yeah, I seem to be double incrementing. Good catch there, double incrementing, and that was because before I was using the the while loop, and so I had put the increment inside the output statement, where in the for loop I don't need it. Good catch. Okay, so again, yeah, they work the same between Swift. So now that I've got my Swift working as well over here, we got it correctly. Not double increment the value as we go through the loop. Now let's see if we can do something similar to the range-based for in Swift. So I'm going to copy this over from C++. Come over here. I'll move this. Let me place that there for the output, the print line. This one, the print line. And let's change the print here. Let's get our ducks in a row with this stuff. We'll say val, so we're going to replace this with val. Okay. So difference here is, right, of course we don't have auto, right? What do we use? We usually use var, but for this loop we don't actually have to even use var. It's going to assume it. And we just change, again, very similar, looks, somewhat similar syntax, a little bit different, right? We basically have pulled out the parentheses that we normally, can take away from C++ to Swift. I could put the parentheses in here if I wanted to, but they are unnecessary, and stylistically you wouldn't necessarily have them. Or actually, in this case, they might not even be valid because we might be looking for a closure. It can't use that because it's the start of a closure. We'll use this one. So in this case, we can't do that, but we can't put the parentheses in this particular type of loop. The range-based for doesn't allow it. This one does because it's similar to basically the C standard, the old C standard type loop. That one still allows it, but the lower one doesn't. So the loop then works the same. Just say val in array. One of the things that you'll notice in Swift, though, is that when you don't specify whether this is var or let, by default it's going to use let. So, and we talked about let being a constant, right? So by default, this is going to end up being a constant type variable rather than a variable. So if I wanted to do something like change the value, val, equals val plus 4, something to that effect, this would actually be a compile time error because it's not going to allow val to be on the left-hand side of the assignment. You notice that it says cannot assign let value to val. And that's because by default, if I don't specify it, it's going to end up being let. I can change it by, again, having to use a little bit of precedence here and put in the parentheses operator. If I just put var val, the compiler would be confused again just because of the precedence of the in operator. But in this case, I can say this allows me to make this change. However, it is not actually making a change to the internal value of the array. So if you notice, I'm printing out val because val is changing. But if I copied this here and I tried to reprint, so just trying to reprint out the original array, all the values in the original array when I was done. Okay, so notice I tried to make the changes in the middle one. Here's the printout of those changes in the middle one. I did not actually make the changes to them. This is not something you can do with this type of loop very easily at all with Swift. If you want to actually make changes, you need to use this type of loop or another one using a range. But in C++, right, we can do it a little bit easier. We can basically say that it's a reference type. And if this is a reference, it's actually a reference to the value in the array, which means that if I say val equals, val plus 4, and then I try to reprint the array after, this will actually make a change. I'll take this one out, so I'm not doing that. Make a run for it. Okay. And notice that down here, the second print of the data from the original array is actually changed. Okay, the data has actually been converted. Okay, so we're getting close. I can't remember, we're already at 10 minutes left. So I did want to discuss one other thing because I think it's a significantly important bit of the differences kind of between Swift and C++. So I'm going to jump to that. We're not going to talk, I'll do real quick about functions, and then I want to talk about class here. So let me dump this stuff on arrays and loops. Finish the arrays and loops, and let's talk about one other thing here. Okay, so just on functions, functions are pretty similar in the way that we address them I see a hand raised, but I don't see a question. Somebody have a question? Go ahead. Okay. Let's see if it's in the chat. No. Okay. All right. If you go ahead and type your question into the chat if you want to, or into the questions, and I will try to answer it in just a minute. But let's go ahead and go through this one. Okay. So what was I going to say? Function. So to define a function, use the func keyword. Notice you don't specify the return type first. You basically just specify the func keyword to say that you're going to be creating a function. I'm going to specify the name of the function, process, and then it's going to have a parameter list. And the parameter list is you're going to have to specify the parameter name and then the type of the parameter. Because remember, Swift is a type strict language just like C++. So if I'm going to put in, say, x, and the type is int, and then y, and the type is also int. And we'll just do something like, for right now, we'll just print out the values of x and y with separated by a colon maybe. So backslash x, colon, and then backslash y. Okay. And then if I wanted to call that function, I just invoke it, again, just like I would with positional parameters in C++. So I say process, and notice the IntelliSense gives me, okay, well, there's x, pass the value there, 3, tab, pass the value 5, and then if I clear my output down here and I run it, sure enough, I get 3:5, which is what I want printed out. If I want to move this to C++, I can do that. And in C++ 14, I can do it without a return type. So I start here again with auto, and then the parameter list is a little different, right? The way we specify parameters is kind of the reverse way of doing this. I'm going to say int x and int y, okay? And then the way we print that out, of course, is this is just the difference between stood, cout, x, the colon, and then y, and then a backslash n, my colon, okay? And then to invoke it, though, is the same, pretty much positional process here. Again, the IntelliSense is helping me saying int x, I'm going to say 3, and int y, I'm going to say 5. And the only difference is I have to have that semicolon. If I clear the output and I run it, then of course that runs fine. Now, if I actually want to have a return value, so let's return, say, the sum of these values here. In Swift, I use a trailing return type because that's what's necessary for me to specify what the return type happens to be. And I'm going to specify it as int, and then I'm going to have a return, and then x, let's just do the sum, x plus y is the return value. In C++, you can do the same thing. You can have a trailing return type syntax, so I can say auto, and then that. I can have the trailing return type being of type int, and then I can have a return, and then x plus y, semicolon, okay? And this one should run as well. So cleaned up, build succeeded. This one runs as well. They're both clean. In C++, also in C++, this is a C++ 11. You're going to have this trailing return type. Usually not for something as simple as this. You could leave it off. But in C++ 14, even if it's even more complicated, you can leave it off, and it'll deduce what the return type is when it runs it. In Swift, you have to provide that trailing return type. Of course, there's other ways to declare functions in C++. I'm not going to go over those right now, but I'll do them in just a minute. I have a question here. Does function have any scope, global, static, file, extern? Yes. So by default, these functions here are are global functions, right? Just like this one is, same type of thing. I'm not specifying that this is static or file scope. These are global functions in the same way that these ones are. If I'm not going to talk about member functions or internal functions, which are the other level there, I think I'll say that I might have to do another webcast here. Didn't realize it was getting so late so quick. Okay, so let me just show a couple other things about functions here that I think is the significant difference here in C++ and Swift, is that in C++ we are always the overloads that we're provided or allowed to do is the number, type, or order of the parameters in the parameter list. And the parameters are always, the parameter names themselves are always internal, meaning that this x, right, only exists internal, and the way it's matched up between the x in the call and the x internal to the into the function implementation is the fact that it's positionally determined, right? 3 is going to be x and 5 is going to be y. Now, although they're also positionally determined here in Swift, there's something else that you can use, which is kind of a carryover from Objective-C, and that you can have external named parameters. And what I can do is if I put a hash here in front of these types, the names of the parameters here, this is telling the compiler I want this value to be used both as an internal and an external name. And that actually gives me 2 overloads. Notice I'm not getting an error from these 2 functions that look pretty much exactly the same in their parameters, right? But they're actually overloaded and they're actually different. And the way you can tell is if I try to use the IntelliSense to call the process function again. If you look down here in the bubble that's come up here, the little menu that's popped up, you see on the 3rd line down, it's specifying, oh, this is the int process that takes an x and a y. And if you look at the process itself, where it's highlighting in the light blue here, it's highlighting the entire space for this parameter. This is the parameter list that does not have external names. So when I call this function, it's just like I did on line 16, which is process 3, 5. But if I move down to this other version of the process function, the overload here, you'll notice that the little blue highlighting on line 18 is now actually on just the type there, leaving the x colon and the y colon to be visible. So if I tab over here, I can put 4, 7, and just to prove that there are 2 different functions being called, I'll put in front of this, say, external, and put this one as internal. And I'll say names, because it's the internal names and the external names. Okay, internal names and external names. So now if I run this, you'll see that the first invocation of the function down here in the output is the internal names version of the function, and the second version over here is the external names of the function. So you can overload quite a bit on using these internal and external names, and the rules for them in functions, according to whether it's a global function like this or a bare function, or whether it's and it's actually a bare function because it's still internal. Global is a little bit broader than that. It actually has to be within inside a module. But the function itself, whether it's a bare function or whether it's a member function or whether it's an initializer, it's going to have a few different rules on how the internal versus external names are used. Okay, well, it looks like we've actually reached the end, and unfortunately I didn't get to another portion that I wanted to discuss, which was structures and classes, because there is a significant functional difference between the way we look at them in C++ and the way they're looked at and used in Swift. So maybe I will put together another webinar and we can discuss that. But are there any questions? Yeah, I do want to try to see if I can get some other questions before we go ahead and sign off. Let's see, I have another one here. And this one says, when it is external, is its reference type or value type? So that has to do with whether it's a structure or a class, not whether it's internal or external. The internal and external name strictly has to do with with how you invoke the function. Whether you invoke the function using the names as parameters, or whether you just do it strictly by positional arguments. So it has no bearing on whether it's internal or whether it's reference type or value type. All right, are there any other questions? So again, the video of this will be available. We'll put it up on the Developmentor website so you can watch and review it. And then hopefully in the near future, we'll have another session, another webinar, if there's interest for a discussion on the value type versus reference type, which was kind of the last question that was asked there. One last question here. Could I call process y5 and then x3? The answer is not with these particular versions of the overloads, but I could provide an overload just so you guys can see this, and then I'll sign off after this, is that I would have to switch, and this is yet another overload. So again, just because they're internal, external names, it doesn't change that they're still positionally evaluated. So this is, I'll just say external names y comma x. This is the other one, and I can invoke this one by instead saying y is an external name and then x. So no, you cannot just use the external names and put them in any order you want. You still have to put them in positionally, but you can have the overloads that are available that then of course show you that the overloads are in the reverse way of doing it. All right, so thank you all for attending. Like I said, we will have the video up on the Developmentor website. And again, thank you guys very much. I'm going to sign off.